Hey everyone, welcome to this first part of creating a decentralized payments protocol. It is a derivative of the work that we did at Purple Pay. So therein we had a structure. Actually, let me take a step back and let me get into how a particular payment pipeline works. So generally there is a merchant that interacts with a large company like let's say Stripe. It provides it a set of backend APIs, and using that the merchant shows its particular web page and the payment details, or I should say order details, to the user. The user then uses those details to make the payment, and this is the event. What this essentially uses is all of Stripe's backend and their abilities. So all the transaction between the different bank accounts and all that layer is happening in the background, and this is what Stripes keeps listening to, and eventually updates the state of the merchant. So this is like a very high level overview, just like when you get a QR code, you scan and pay using Google Pay, and the QR code or the merchant or POS that is provided the QR code, it keeps listening to the NPCI server or the UPI protocol for confirmation against that particular transaction ID. So what we did at Purple Pay was also very similar. We just started that we were onboarding the merchant, and we were providing the merchant with an API key. Then the merchant was showing its QR code, etc., to the user. User was making the payment. This was instead of the banking layer, this was the blockchain layer, and Purple Pay was listening to the transaction that was happening there. So a similar kind of flow. Instead of Stripe, we were the payments provider, and instead of the network of banks, it was the blockchain layer. Now, what if we want to remove Purple Pay and in a way open it in a certain way where any merchant can come in and generate a bunch of smart contracts through which they can start processing their own payments without any dependence on a centralized backend server of Purple Pay? How do we go about building that? So this is an attempt to do that. What I'll be doing here is taking the particular factory contract that Purple Pay was using to generate the native and ERC20 burner addresses, and we will be creating a factory of factory contracts so that anyone can come in, use this to create their specific factory contract that can then generate these native and ERC20 burner addresses. And this is the flow that I've thought through. I'll work on it and we'll discover as to how feasible this is and what exactly do we need to make this workable. So the first thing, let's get to Remix IDE, because we can set up a hard hat truffle or even a Foundry repo and do all that. But I wanted to keep it simple. Let's focus on the smart contract writing part of it first. Then eventually we'll set up the entire folder and move the code there. So the first thing, let's quickly create out a bunch of burner addresses for native as well as ERC20 tokens. By burner address, I mean that it uses a create to opcode to generate a unique address to identify each unique order ID. Yes. Let's quickly copy this boilerplate part. Pragma Solidity, just specifying which particular versions to be used. We'll be using a bunch of open Zeppelin contracts and their interfaces. We'll also have an errors file to keep the error messages there. First is the native burner contract. So for any particular payment that is coming in to a specific address, what are the parameters that we need to identify that particular order? For now, all we need are like 3 parameters to start with. Like what is the amount that particular order requires, what is the address for the merchant, and what is the address for the payment gateway, or I should say payment processor. So in our case, it was Purple Pay. It can be anything, and we'll also have a place where the logic says that if there is no payment processor, entire 100% should go to the merchant address directly. So merchant can become their own payment processors in a way. Now for the constructor body, it's pretty straightforward. All that happens is you check if the balance of this particular address is less than the amount required that should have been paid. So this amount represents order amount. We'll also create a quick doc string on top of it. So it handles the payment for payments made in native token. Okay, so the right way to write this is at the param amount is the order amount that merchant has requested. The merchant's on-chain address to which order has to be made. Third piece is the payment processor address to settle payment processor's share of the transaction. Alright, these are the three params that it takes. Now, if the balance of this particular address is less than the amount, all I need to do is revert with an insufficient balance. And the reward will also provide how much balance is currently present in this contract and the requested amount that is there. We can improve upon this as well. Now, what we define here is the payment processor fee. This is basically 1%. The rest of it goes to the merchant. Alright, so this is pretty straightforward. Then to settle this, what we need to do is basically call the payment processor address. Should put in an address here as well. And I should do a call with the value inside it. The value is payment processor fees, and that is all. What it returns is a boolean with respect to success or failure. Now, if fee sent is not available or false, then we need to revert with a failed to disperse fund, or I should say a better name would be failed to settle with payment processor. When you print out the merchant share, actually this is for the processor, so we should put in the payment processor fees and the payment processor address. So first we are trying to send it to the payment processor. If that fails, we are just reverting. Then the second step is, once the share of payment processor is gone or like settled with the payment processor, then you call merchant's address and you settle their share. The call method returns another boolean. If this fails, we will now revert with a fail to settle with merchant, and we'll provide in the merchant share and merchant address. Okay, so this is the basic naive implementation where the moment native burner is deployed, it splits and sends both the payments to the different parties. Now herein, what are the things that we can consider adding? One of the things would be, rather than hard coding payment processor fees, can we add a custom share to payment processor? Handle the case where there is no payment processor. Another to do is handle the case of multi-party split instead of payment processor, which means, can we generalize the splitting mechanism? Okay, so these are the short-term to-dos. Basically generalizing the splitting mechanism here, that instead of 1%, can I provide a specific share, and then that particular fees goes to the payment processor. So this was pretty straightforward. You just created a constructor function so that the moment contract is deployed, the settlement happens. So this makes it non-custodial in a way as well. Come on. Okay, now let's do the same thing for the ERC20 burner. We can copy this entire part. So apart from these three, one more piece of information that we need here is the token address. The ERC20 token address. So we know where to look for. Now we can quickly do this. Everything remains the same. All we need is an additional token address. This is going to be the amount. Another address is going to be the merchant address, and one more address is going to be the just force of habit, payment processor address. Herein we initialize an ERC20 token interface. The given token address. We did not need to do this for the native token, and we check that in the token if the balance of this particular this particular burner address for ERC20's amount or balance is less than the requested amount, then we can just revert with a insufficient balance. And hey, in this particular ERC20 contract, the balance of the address that you provided, which is this ERC20 burner address, is insufficient compared to the amount you requested. Now if it passes that check, then we do the same. Payment processor fees is equal to amount by 100 into the merchant share is equal to amount minus payment processor fees. In the token contract, we just do a transfer to payment processor address, transfer payment processor fees, and for merchant address, transfer the merchant share. So again, pretty straightforward. I think this was a bit redundant here. We did not require this here. Again, very simple naive implementation. We'll do the same to-dos with respect to splitting mechanism and add additional checks. Right. Now once these two contracts are in place, let's quickly create the bunch of errors that we have defined. We have seen our three errors: insufficient balance, which takes in whatever the balance is. Whatever is required. And a couple of errors from native burner. Takes in the amount and it takes in the address of recipient. And the rest remains the same. Also need to add a pausable feature so that we can pause any contract whenever there is a requirement. Let's say there is some sort of an exploit or someone is generating like there's some vulnerability with respect to the keys. Factory contract gets compromised, something happens, we need to be able to pause this. So these are the 4 errors that we'll be working with right now. Alright, so as the first part, we have created successfully these 2 contracts. Now we'll get into the factory contract and write the 2 functions that we required. One is the deploy and one is the predict address. I'll quickly grab lunch and see you folks in about half an hour.